I am obsessed with nature's extremes. I like studying animals that look like they shouldn't be possible.
Which explains why University of Montana biologist Doug Emlen studies these guys.
Let's just put this in perspective. These are among the largest outgrowths of any kind of weapon that you see in any animal.
And you would not expect a beetle that has a giant pitchfork sticking out of its forehead to be able to fly at all, let alone fly well.
That's Emlen's PhD student Erin McCullough, who studies these rhinoceros beetles in the field.
You can definitely hear them sort of roaring as they come to the tree. And they don't land gracefully on the tree, they just sort of like bump into it and scramble off.
They're headed to gashes in the tree where the sap is leaking out.
And the males fight for access to these sap sites.
It's pretty dramatic.
It is dramatic. So they try and pry their opponents off trunks and branches of trees, and it's like a crowbar. You can definitely watch intense fights for hours.
Well, if you're an entomologist. Anyway, it's not surprising these fights are so intense because there's more than sap at stake.
So the females come and feed at these sap sites, and the males fight over access to these sap sites because the males that gain access to the sap sites get to mate with the females.
In other words, size matters.
The males with the longest horns have the highest reproductive success.
That makes the horn something called a sexually selected trait. A la
male ornaments, male weapons, the tusks of elephants, or the long tails of birds. There's this idea that sexually selected traits, they'll keep getting bigger and bigger until there are some fitness or survival costs that ultimately limit how big they can get. It's interesting in the beetles that I haven't found any evidence that there are important fitness costs. The horns don't appear to be costly in terms of how well the beetles fly. The horns don't appear to stunt the growth of other structures.
So if costs aren't limiting size, what is?
I think is going on in this species is that the horns reach some sort of mechanical limit.
They snap, which is no good for beetle battles.
No, if you have a broken horn, I think you're out of the game when it comes to prying off your rivals.
And what causes the horns to grow big in the first place?
These traits are exquisitely sensitive to nutrition.
Specifically, the insulin pathway regulates growth, Emlen found. So a beetle can't grow a big horn without being well fed, but once it has one, it seems like there's very little cost to pay. And that might help explain why these extreme extremities exist in the first place.
If they're not costly, then the beetles are sort of free to take on a bunch of crazy horn shapes and sizes.
I think I've heard of that idea before. Cutting costs leads to growth. For Science Friday, I'm Flora Lichtman.